Hello students, Stride here again. Today you're looking at section 13.1, fluid pressure. And a little example to start us off with, that theater seats as you're sitting and spreading your weight over a larger area, much more comfortable than a bicycle seat. So pressure, going to calculate pressure. We need to divide the force by the area. There's our formula. Pressure equals force divided by area. Unit of force we had previously, the Newton. Unit of area, square meter. SI unit of pressure, then is the Pascal. Pascal is a Newton per square meter. Definition for pressure, force distributed over an area. If the area of a box touching the ground is 1.5 square meters and its weight is 2,700 newtons, what pressure does it exert on the ground? We get 1.8 kilopascals. What I would want you to do with a problem like this would be to, again, write out what we have. And we do area is 1.5 square meters. Its weight, which is a force, weight is a force. It's 2,700 newtons. And then when we were dealing with Newton's second law, I had you break newtons down into space units. Here we won't need to. So formula, pressure equals force over area. Pressure equals force was 2,700 newtons divided by area of 1.5 square meters. Newtons per square meter is Pascal, are correct units. Little division, and we do get 1,800 pascals, and a very common unit of pressure is the kilopascal. Dividing this by 1,000, moving our decimal back 3 spots, the pressure then would be 1.8 kilopascals. Key question, how does water pressure change with depth? And how is pressure distributed at a given level in a fluid? Water pressure increases as depth increases. Pressure in a fluid at any given depth is constant and exerted equally in all directions. A lot of key ideas in that little statement. Fluid assumes the shape of its container. Gases and liquids are fluids. And then here we have some examples of fluids. Here we refer back to some things we learned quite a while ago. But particles in a liquid, tightly packed, but able to slide past each other. That's why it can take the shape of its container. Particles in a gas, though, are far apart, travel in straight lines till they collide with something or an object. Water in a glass, contact with the walls, and exerts pressure on these fluids. For fluid not moving, depth and the type of fluid are two factors that determine pressure. Each vase holding a different amount of liquid. The liquids are all the same level because pressure depends on depth, not amount. So note that these are all the same level, even though there's a lot more fluid in this one than there is over here. But they'll balance out. Here we get a little information about the atmospheres of our planet. Layer of gases surrounding a planet is known as its atmosphere. And all the planets in their atmosphere have some, or in the solar system have some sort of atmosphere. And the weight of an atmosphere creates atmospheric pressure. Number 1, which planet listed in the table has the greatest atmospheric pressure? Look at that, see if you can figure out the answer. And here, give it Venus at 9,120 kilopascals. So we can see this much greater than all the other ones. And what chemical substance exists in all but one of the atmospheres? And look at it, try it. And we see nitrogen. What chemical substance exists in all but one of the atmospheres? Nitrogen is there. Nitrogen is there. Nitrogen is there. But we have no nitrogen in Mercury. And some converting units. A bar, another unit we use. 101.3 kilopascals, and we want to change each of these into bars. So each one would be dividing by 101.3 kilopascals. And after we do all that division, Earth, 1 bar, that's considered our standard atmospheric pressure. Venus, 90 bars, 90 times the pressure of Earth. Mars, not much pressure, 0.007, and the one that was a little tougher, Mercury, and that's supposed to say 10 to the negative 15th bars. Just a little division there. And how much force is exerted on a 2 square meter area of Venus surface? Oh, our formula is pressure. There's what the book did. I'll write it out in a little different fashion. Force divided by area. So we want to know how much force. So force equals pressure times area. Force equals our pressure was on Venus is 9,120 kilopascals, and so 9,100 kilopascals, and we want to take that times the area, which is 2 square meters. Now, we don't want to put pascals in here. What we want is kilonewtons per meter squared. Then the meter squared divide out. And a little multiplying, we would get 18,240 kilonewtons. That's kind of an odd way to express it. And we only want 3 sig figs, so we'll just keep the 182. Kilo means 10 to the third. We have 1, 2, 3, 4 spots here, so that's going to be 4, 10 to the 4th, giving us 10 to the 7th. And I'm going to, instead of saying 2.00, I am going to say 1.82. Times 10 to the 7th newtons. On which planet would a balloon filled with a given quantity of helium have the smallest volume? Smallest volume going to occur at the highest pressure. So we can see Venus. Smallest volume, greatest atmospheric pressure. Causes that balloon to shrink down. Air pressure in the atmosphere. How does air pressure change with altitude? As you go higher up, the air pressure is going to decrease. Earth's atmospheric pressure about 101 kilopascals at sea level. Why aren't you crushed by air pressure? 101 kilopascals is a tremendous pressure. But pressure inside our body balances out the pressure outside, and these cancel, resulting in a net force of 0. Might have experienced in an airplane as you take off and fly up, your ears might pop. This is the pressures equalizing, because as you go up, pressure gets less, and your pressures inside and outside try to equalize. An example here of what happened with pressure. Can containing a small amount of water heated until the water boils. Can is capped. As the can cools, pressure in the side becomes less than the pressure outside, and it will end up crushing the can. And the gymnast standing on one hand, area 0.02 square meters, pushes down on the ground with a force of 600 newtons. How much pressure does the answer ends up being B? That pressure equals force divided by area. Our force was 600 newtons. Our area was 0.02 square meters. We'll divide in there and we get that 30,000. SI unit of pressure equal 1 newton per square meter is called a Pascal. Pressure exerted by a stationary fluid is determined by type of the fluid and its depth. And some things that don't affect it. Volume does not affect it. Shape of the container doesn't affect it. Weight of the fluid does somewhat affect it. And which of the following statements about fluid pressure is false? And we see C, the pressure in this fluid is exerted downward. Pressure in the fluid is exerted in all directions. And why do mountain climbers on very high peak need cylinders of oxygen as they approach the summit? Pressure decreases as altitude increases. So less pressure and need more help getting the air into our lungs. And also as we go up, another related reason is the level of oxygen tends to decrease also. So that's all we have for 13.1. That's all for now. Till next time. This is